My name is Dustin Bajer, and I'm a teacher with Edmonton Public. And I've been working for the last 3 years at Jasper Place High School. And so we started a program there simply titled JP Permaculture. That what we're doing is we're taking a look at a lot of ecological patterns and principles, and then trying to apply that in designs within the school. And so these designs, the idea behind them is they can benefit people and they can benefit ecology at the same time. We don't have to do one or the other. We're not, as a species, we're not inherently evil. We're not inherently destructive. But we can use nature, we can use ecology, and we can follow those patterns, and I think create some pretty amazing things. So today I'm going to share a little bit about what we've been doing at the school. I'm going to talk a little bit about some aquaponics. And then I'm going to talk about a lot of metaphor, and if you were in my last presentation, you heard me rant about connections, and I'm sorry, I'm going to rant about connections again. You may well notice, so a permaculture approach to education. I am a teacher, and so being in a school and teaching biology, and then going and working with ecology and trying to create these designs, it's hard to not, and being obsessed about connections, it's hard to not draw from that and bring it into sort of the social aspect of teaching. But I also want to talk about movements, and I think that's something that everybody in here is interested in particular the food movement. And so I'm going to meander a little bit onto that topic and offer at least some of my thoughts around that, which, once again, hopefully will be useful. So a little bit about the ecology, or a little bit about ecology. This is a mirror web, and a mirror web is just a representation of an ecosystem. And so this web represents living or non-living components of an ecosystem. It is, I guess, the web of life. And this might be a tree, this might be a particular type of soil, this might be some water. Well, actually, water is kind of connected to everything. And these lines are links, connections. And so if you look at this, and you have, if this is a forest and we have all of these producers, and they're capturing and they're storing light, and they're making sugars out of it, and they're making energy, and that ends up being cycled over and over again. If you were to put a drop of water in this system, it might get taken up by a plant, then eaten by an animal, and moves through the animal. The animal sweats, and that ends up being absorbed by, let's say, some leaf litter, taken up into another animal or another plant, and it can cycle over and over and over again. You can imagine putting some water in this system here, and it's cycling for decades, perhaps. If you put a drop of water on a piece of concrete out in a parking lot on a sunny day, it is gone. And so how do we create systems that take all of the available resources, soak them up like sponges, use them continuously, and become productive? And so this here is a project that we did at school. We did this particular project 3 years ago. This is a courtyard here. We have 2 ornamental crabapple trees and 2 patches of lawn. We didn't do any tilling, with the exception of this trench that we dug around here. And it is a nice little microclimate, so things are generally still pretty green in October. It also, definitely in April, things are looking pretty green as well. So it is a lot warmer in here than you'd find outside of the school even. And our goal was to create a system that would be a learning resource. We could bring in the community. It would tie various curricular outcomes together, so biology, social studies, art, design. We wanted to be able to produce food from it. We wanted to build biodiversity. It should sequester water, so it should absorb water like a sponge. It should decrease our waste, so it should absorb that waste. And so we turn to, like a lot of permaculturists do, to ecology, to ecological systems, because forests do that. Nobody waters the forest or tills the forest or weeds it or goes around and squishes all the little bugs, and because of the tremendous amount of diversity in there, because of all of the connections, no one thing kind of takes over, right? It doesn't mean you're not going to have pest problems. it means that the likelihood that that one pest is going to take everything out is very low, unless the whole system is really stressed. You can have a decade of drought before forests start showing signs. And so there's a tremendous amount of resiliency in there. So how do we take that and apply it here? What we did is we first kind of started with water. The big question was who's going to take care of it over the summer, and in the interest of my own personal life and my own garden, the answer had to be nobody. And so what we wanted to do was work with the water that would fall there naturally, use it over and over and over again like a forest so that we don't need to be there watering it. We did simple little things like this. We dug this trench around here, and we have all of this water that would land on the garden, but we have all this water that would land on the concrete. And in the past, that water's hit the lip, flown down and into a drain in the center. And so what we did is we punched holes in this lip so that the water would actually run into this trench. It's a little bit light here, but it would run into this trench and completely surround our garden. The next thing we did is the soil from that trench, we actually kind of made a bowl shape so that water that landed in here wouldn't spill off onto the concrete. And so the water that landed there stayed there. This is 50 bags of yard waste. So when you send an email out to your staff and you say, hey staff, please bring in your yard waste, they look at you like you're crazy, but they happily do it. It's free, it's a waste product for them, so it is doing that cycling like an ecosystem would, and we're able to add that to our design to make beautiful soil. We brought in 26 cubic yards of straw, which we added on top of everything. We didn't replace the soil there. We didn't buy in any soil. We made it all on site in what's called a sheet mulch. Who's familiar with sheet mulching? So, okay, so a decent number of people. Here we are mid-project. So we have cardboard on the base to keep that to keep the grass from growing up, and then we have a foot of organic matter. And so there's our another. If you take a look at a forest, you see all of those layers in the soil, and you have the decomposing layers on top. And it's more decomposed the further down you go. And so we're trying to mimic that. So water lands on that, and it just soaks it up. I've never seen water run out of this thing. It's amazing. And so putting that foot of organic matter in there. There's our water harvesting trench here that we placed. So those holes are punched in there, and that's just an aggregate weeping tile pipe just to keep water moving around. And then we covered the whole thing with 2 inches of compost. And so this is what it looked like right before we planted in it. So make a little pocket, throw in some compost, put your little plant in there. And what we did is we put in 80 different species of edible perennial plants. And so going back to the perennial thing that Anita talked about. So when you have, the raspberries, when you have, we have grapevines, we have all sorts of various herbs, and some of them are giant, like lovage, which is just an insane parsley type thing, which is really good in soups and stuff. And so lots of currants, gooseberries, and so it's just this kind of mishmash of perennial plants. This is Dragos. He's a member of the Permaculture Club, and he's putting an understory of strawberries into the garden right now. He's also standing on some cardboard because the ground is really, really spongy, and so we're trying to keep it that way. I always tell the kids, don't treat soil like dirt. And so, walking all over it, and yeah, don't treat it like dirt. Within a couple days, mushrooms popping up, which I was really excited to see. You don't typically see that in a regular garden. We actually inoculated the whole thing. We took fungal spores and spread it throughout the garden to increase that microbial life. A really cheap solution. We found some wood shavings from the construction class, and we covered it on top. Something like a log, you wouldn't necessarily think that would do a lot, but if you think about all of the potential connections that even a log could have in it, so all of the organisms that live on it, in it, under it, the little microclimates on either side. This log has pretty much disappeared now, actually. So This is June 15th, 2010, I think, 2010. June 15, 2010. And this would be a couple weeks later, so just coming to check on it over summer. Yeah, so you can see here this is not a typical garden. If you were obsessed with straight lines and you would hate this. I personally like the green disheveled look. And so this here is towards the end of summer, same garden. We have some annuals in here, in particular a lot of beans to fix nitrogen. We have some nasturtiums in here which are pretty tasty, but other than that, it's pretty much perennial plants. And so this here is, actually this here would be the spring of the following year. So this would be about June 15th, the year before. Or sorry, the year after. And so we have this perennial food producing system that comes back every year. We take waste, we take just leaves and stuff that the custodian staff rakes all of the leaves. I haven't been able to convince them to not rake the leaves, but I have convinced them to hold on to the leaves, and so I can do what Anita does and steal them and spread them all over the garden. Growing under trees, brilliant, love it, amazing. All of these leaves every fall, right on the ground, right where they need to be. So you have that forest, beautiful forest soil kind of developing all the time. Lots of birds in here now, there was none before. We even, I'll be a couple pictures back. We even have, oh, he's not there, our little JP squirrel who's moved in. I once heard a quote that I really like. It's that you can measure the strength of an ecosystem by the health of its top predators. And I guess ours is the JP squirrel. I'm not really sure what that says about the garden, but the fact that he's there now and he wasn't before is kind of nice. I like there.
Courtyard. How did he get in there?
Coming over the top, coming up and down. Yeah,
Okay.
yeah. So no problems there. But you're right. It is enclosed, but things find their way in there. So to talk about resiliency, to talk about connections, I like to think of resiliency as a measure of how connected something is. And so in a garden, that is could be something as simple as how many different ways does this garden get water or hold on to water? And so there's rain, there's the passive water harvesting system, so that excess water that the concrete moves in. There's the 26 yards of straw, of organic matter that soak things up. There's the mycorrhizal fungi that we put in here, which should go out and find water. And the mycorrhizal, like the fungi, actually has, according to a gentleman named Paul Stamets, in a cubic inch of soil, you can find up to 8 miles of mycelium, which is that sort of white fibrous stuff that is the body of the fungi. So this is actually the fruit of it. But it's way more efficient at going out finding nutrients, finding water, than plant roots are. So it'll partner with the plants in exchange for sugars. We have a drip line system. I lost track. We have a drip line system, which we haven't been using. And then, we have a mulch to protect, to keep evaporation down. And then we have, the gardener going out there and watering. So only if all of these other sources of either bringing water in or holding onto the water fail, do you actually have to go and water it. So that was part of the design. To go on a little bit of a teaching tangent, spending a lot of time thinking about permaculture and spending a lot of time thinking about kids. Plants, kids are basically the same thing, right? In some ways, yes. So this is an ecosystem, and an ecosystem it's like any system. It's made up of all of these connecting pieces, and systems are sharing things. In this case, it's water, it's nutrients, but in the case of a school, hey guys. In the case of a school, you're not sharing water and nutrients, but we're sharing ideas. We're sharing learner outcomes, learning opportunities. And so if this is my model for the garden, can this also be the model for my classroom? And so it's been a really interesting turn that I wasn't anticipating, but I want to share that. This is what I meant by a really meandering presentation. I want to share a little bit of some of the educational philosophy, I think. In permaculture, there's something called needs and yields. How are we doing for time?
About 15.
15 minutes, okay. In permaculture, there's something called needs and yields, and so it's this idea that everything in a system requires certain inputs and offers, certain outputs. So it has certain needs and offers certain yields. And if you can take all of the elements of your design and you can align them in such a way that the needs of every single element are met by the yields of another element within the design, then the whole thing becomes self-containing. And so it's kind of a common permaculture design practice to do a needs and yields analysis of all of the little pieces. To give you an example of, I always think of waste as a yield that doesn't have a use. So if you're yielding something that has no use, it's waste, it's a problem. If you need something that isn't there, then you have to go out of your way to make it happen, and that missing need becomes work. And so if we can create designs where the needs and the yields fulfill each other, then we're actually designing out work, and we're designing out waste or problems. There's a famous Jeff Lawton quote that says that you don't have a grasshopper problem, you have a turkey deficiency. And I love that, because it's playing around with that idea of needs and yields. So the problem is not a problem, it's a yield that isn't being used. The grasshoppers are an unused yield. What needs grasshoppers? And so all of a sudden, by adding something else into the system, it becomes a solution. Here is the Culinary Arts program. This is Ms. Hobbs, the Culinary Arts teacher. And it's an amazing program at the school. It's one of 2 culinary arts programs in the province that actually produce all of the food for the school. They even do catering. And so there's 30 kids in there. They take everything from scratch, and they completely run the cafeteria. Big commercial kitchen, big industrial equipment, and they make beautiful, beautiful things. And so they have certain needs: teachers, people to feed, funding, students, ingredients, and they offer certain yields. Hopefully industry leaders, they make a little bit of profit, though as a school, they're obviously not out there trying to compete with, take profit away from private businesses. But they also offer food scraps or waste. And so you look at that, that's a problem. That is a yield that is not being used. We have some worms, on the other hand, which have all sorts of needs: food, water, other worms, love. And they yield things, including more worms and lovely compost. We have some fish that have needs and yields as well. And we have some plants that offer, that in addition also have some needs and yields. And individually, these are interesting things. And individually, you might be able to find these, a club, a culinary program, some plants, maybe some worms, maybe some fish, I don't know, maybe goldfish or whatever. You can probably find these things in a typical school. But I think that things become really interesting when you start connecting them, so that the Permaculture Club is growing plants that head to the Culinary Arts program. And the Culinary Arts program makes scraps that are given to the worms, and the worms get fed to the fish, and the fish get sent back to the Culinary Arts program. And so you end up with something, let's see if this plays, you'll end up with something that is a little bit more self-sustaining. So this is this is just a conventional fish tank, but we'll show you the larger aquaponics tank here in just a second. And so here is our main tank. It overflows into a reservoir here, and it's pumped back up through this. There they are. Yes, that's the fish. And so this is called a chop system. So it's this flood and drain bed. And so up here we have all sorts of vegetables and various things. And this runs continuously. And in all of this grow bed is bacteria. And it's going through the whole nitrogen cycle. So it's taking ammonia and it's converting it into nitrites and nitrates, and the plants are taking that up, which in and of itself is an awesome biology experiment or demonstration. But it's tying all these other elements of the school together in, I think, a really interesting and meaningful project. So, is this? No, but it's starting to think about things in that way. Just like the Food Forest project is starting to emulate these kinds of patterns as well. To the education piece, what are the needs and yields of a learner? And I think every single student has different needs and yields. And what are the needs and yields of a particular learning environment or classroom or course or school or community? And how can we tie all of those things together so that all of the yields fulfill the needs? And so it becomes this resilient system, this connected system. I'm going to skip through this. This is typically how we move through a course. So learner outcome, learner outcome, learner outcome. We'll bundle that into a unit. Bundle a bunch of units together, we'll call that a course. What if every learner outcome could branch off to multiple other ones? And what if through pursuing projects, you end up hitting these outcomes and sometimes crisscrossing and mashing and colliding with outcomes you've already covered across disciplines. So, instead of looking at this is physics class, this is math class, this is biology class, how can we get that cross-curricular connections going? And I think mimic something that more closely aligns with nature. I think also aligns with neurology, because I think you get that same kind of branching pattern there. I don't think that that's a coincidence necessarily. So, a social movement, something like a food movement. In permaculture, we often talk about, how am I doing for time? 10 minutes? Okay. In permaculture, we often talk about the edge effect. And in biology, we talk a lot about ecotones. So an ecotone is where one ecosystem meets another ecosystem, and they're overlapping in that ecotone. So you have all of the diversity and connections of this ecosystem, plus all of the diversity and connections of this ecosystem meeting in one place. And there's also a band of organisms that just strictly kind of inhabit that area. So if you think about a forest meeting a lake, and so that littoral zone there, that beside the lake, and so. In permaculture, if connections mean resiliency, and there's more connections at these ecotones, at these edges, then how do we create those edges? And so in a food forest, this might mean making the actual shape of the garden different, meandering presentation. Socially, I think that's a little bit trickier to do, but let's imagine that this is any kind of movement, or for our purposes, a food movement. And this here is, let's say, I don't know, the magic person who can pass the legislation or whatever and can make all of our wildest dreams come true. I think what happens is you move through a sort of a succession. You can't necessarily get to this person. You need to move through those social networks. If you are into food and those people around you are connected to you, to go to the very top and convince that person may or may not be within the adjacent possible. But dealing with those people that are immediately around you and expanding that edge and getting them on board, and they further network out and touch on those the next people, I think that you can move through something that looks much like a forest. So, oh man, I gotta go quick. So, in ecology, you can move from something like a parking lot. I always ask the kids, what does a parking lot want to be? Or what does your lawn want to be? And it sounds like a really strange question, but if you leave your lawn or your parking lot unattended on a long enough timeline, it will turn into a forest. That is the state that it would be here in aspen parkland, which by the way is a ecotone of the Great Plains and the boreal forest. And so, you know, at first, you're going to get little cracks in the concrete, and you're going to get those little seeds in there, and you're going to get a little bit of water, and you're going to get that little seed's going to germinate, and it's going to, the water freezes, and it freeze-thaw, and that crack gets a little bit bigger, and that edge of that crack expands ever slightly, which makes a little more edge for stuff to get hung up on, and more dust, and more seeds, and you get that, those fast-growing annual plants, those pioneer plants that we call weeds, and they start breaking up that concrete a little bit, and they make more edge, and more stuff piles up against it, and more water, and it dies, and it deposits organic matter there, and it keeps building, and the crack gets bigger, and a flower and a bug comes, and a bird comes, and leaves a deposit, and the whole thing cycles up, and on a long enough timeline, you're going to move through this, and you're going to end up with a forest in that parking lot, or a forest on your lawn. Your lawn wants to move that way. Life creates conditions conducive to life. And as a teacher, I like to say that learning creates conditions conducive to learning. And I think movements create conditions conducive to the movements, to the end goal. But there is a succession. You can't just go straight from here to here. Where we are in Edmonton or where we are in Canada, I'm not sure, but I'm optimistic that we are moving in this direction, that we are expanding the edge, we are breaking apart the concrete, we are moving through succession. And I think building resiliency, building something that looks hopefully a lot like this. And so, for me, I guess the main message and why I love permaculture so much is it really, I mean, it's really easy to look at a forest and not see all those connections that are happening there, but when you sit and you observe and you think about that cycling and you think about those patterns, and there's I find so much joy in being able to test those out in my own designs, especially doing it with students. I think we have a lot to learn from this, and if jump on board and help build those connections and that resiliency.